Okay, I did some calculations, and I noticed that the minus 1.3 centimeters is just like this right here. So my distance actually is going to be very close to the focal point, it looks like. There's my image right there. It's going to be very, very close to that focal point. Very, very close to half an inch. It's going to be very, very close. So therefore, my distance of the image is going to be very, very close to minus 0.5 meters. I converted 0.5 centimeters for the height into inches, and it's 0.20 inches. So if I convert that back into meters, I get 0.20 meters. So these are the drawings, these are the approximates that we've gathered by this. Now we're going to do the calculations using the lens mirror formula and the magnification formula. So the lens mirror formula is the inverse of the focal point, is the inverse of the distance of the object plus the inverse of the distance of the image. We're trying to solve now, and these are what we're going to be using for the actual values now. This is an estimation, this is our actual values. So we want to solve for this. So the inverse of this, we need to subtract the 1 over DO from both sides, is the inverse of the focal point minus the inverse of the distance of the object. If you get your calculators, 1 over the focal point, 1 divided by, and my focal point, remember, is negative 0.5, minus the distance of the object. Distance of the object is 5 meters. So it's going to be minus 1 divided by, it's the inverse of the 5. So we get minus 0.22, and we're going to take the inverse of that answer to get minus 0.45. Distance of the image is minus 0.45 meters, which is very close to the focal point, which is very close to our drawing right there of 0.5, minus 0.5, minus 0.45. Now the next one is to find the height of the image, and we're going to use the magnification formula. High over ho equals negative di over do. We multiply both sides by ho. So the height of the image will equal negative distance of the image. Now don't use our estimates, we're using these things right here. So we just calculated this, minus 0.45 meters. Actually, it's a negative of that, so it's a negative 0.45. All over the distance of the object. Distance of the object is 5 meters, times the height of the object, which is 2 meters. Okay, so those cancel. And again, we have the negative of this, negative dido, but then the distance of the image is a negative already, so a negative of a negative will give us plus a positive. 0.45 times 2 divided by 5 equals 0.18. The calculated height is 0.18 meters, and our estimate by the drawing was approximately 0.20 meters. So we were close. So this is showing the calculations for a convex mirror.